Good afternoon, gentlemen. Good afternoon, all attendees. Welcome to the Ocean Protect webinar. Looking forward to getting some insights into the world of the OceanSave GPT from a couple of gurus in Daniel Page and Damien Egan, Esquire. Welcome, gentlemen. You well?
All good.
Doing well.
Very good. Very good. Look at the different themes we've got in our background. We've got Daniel, who's calling in from Sydney. Damien, who's calling in from Melbourne, living the dream in Melbourne, and obviously I'm in God's country of Brisbane, so certainly got a interstate connection across 3 states. That's fantastic. And obviously Ocean Protect, we've got offices in all 3 states, and certainly these gentlemen are stars of our respective locations in those areas. Just a reminder for those, just a few sort of housekeeping things. Just a bit of a background before we dive into the official proceedings. So this is actually our 9th Ocean Protect webinar. Today, again, it's been very popular. Again, this is another very, I guess we're sort of continually amazed by how popular our webinars are. We do have, I've just inserted a link into the chat. We've got a couple of webinars already organized in the coming months. The first one being, it's a webinar by Ben Peneleric, who's from Griffith University, and he's presenting on October the 6th, and it's called Learning from Ecosystem Management to Overcome Challenges of Affecting Vegetated Stormwater Treatment Assets. And that's might be the raw appeal of Ben, but or the amazing topic, but that's already got well over 100 registrations already. But again, to register for these webinars, just jump on that link I've just posted, the Ocean Protect website, under the webinars tab. And in November, we've got a presentation by Mindy Hills from Virginia in the United States. And she's, her presentation's called Ensuring Bioretention Media Performance Success. So, but, and on that same link, if you've missed any of our previous webinars, all our recordings of those webinars are available under that tab. Another one of our sort of educational initiatives is the Ocean Protect podcast. Now, would you believe, I think we're about 114 episodes deep. I've just included a link to the that podcast. You can listen to it anywhere you basically listen to podcasts, iTunes, Spotify, etc. And our most recent chat is with Jim Lenhart, who is a very well-respected individual, a lot of experience, I think about 30-something years of stormwater management experience in the States. And it's a fascinating chat. So if you like your podcasts and you like hearing people talk about stormwater, which I assume you do, if you're here today, you'll certainly enjoy that little episode. And there's obviously a stack of different topics. Obviously, we're here to talk today about the OceanSave, and I'll include a link in the chat which is obviously just from our website. So there's a whole bunch of information on that website link. And you might hear the guys talk about a white paper in particular, which talks a lot about, goes in a lot more detail than we have today. And you'll find the link to that white paper at the bottom of that link as well. Cool. So without further ado, I think we might officially kick off things. So look, today is about the title of this webinar is Best Practice Design and Management of the OceanSave GPT. It's all about providing an overview of the OceanSave GPT, its components, performance, how to design, install, and manage these assets to ensure their optimal function. So we're going to hear from Damien and Daniel, a short presentation, probably about 20 minutes. And then we'll have questions, we'll go through any questions from attendees. So if you do have a question and you'd like to pose it to Daniel or Damien, please put it in the Q&A bar. So it makes it a lot easier for us to sort of respond to each question. Some people make a mistake of putting in the chat, but please, it's all good putting in your comments and whatever heckles in the chat bar. But if you want to have a question answered, please put it in the Q&A. Cool. But look, without further ado, so the two gentlemen we've got presenting today, Damien Egan and Daniel Page. So Damien is a civil engineer and Ocean Protect's national sales manager. And he's got some over 25 years experience, which is incredible because I think he's only 26, 27. That's what he tells me anyway. And Daniel is similarly a wealth of knowledge. He's Ocean Protect's guru and has been designing these and other stormwater treatment assets for over 20 years, would you believe? So very impressive. Look, but without further ado, I might pass you over to Daniel and Damien.
Thank you. Let's start by introducing the fact that I previously did one of these webinars, I think it was towards the end of last year. And in that one, we covered some of the history of GPTs, the various types of GPTs, you know, how they perform, and went into quite a reasonable amount of detail about the key design sort of considerations that, you know, a designer should really consider, you know, in working out and sizing a GPT. So I don't want to necessarily cover all those again today. This is more of just an extension of part of it, a rehash of some of it, and it's designed more to give you a little bit of additional information, a bit more comfort on what the OceanSave actually, you know, is and does and fits. So the first bit of information that we're going to go back on a little bit is perhaps to revisit the actual types of GPTs. So you can see a few pictures of types of GPTs here, but they are actually grouped. So now where we're going to start here is the question phrased is, you know, how is the OceanSave different to other GPTs? Hence, we need to know what the GPT grouping are. Now, this question though reminds me of a discussion I had some months ago when I was talking on the phone to a very young engineer, and I was explaining the differences between the various types of GPTs. And he stopped me during that conversation and asked, what do I mean when I say that oils ain't oils and GPTs ain't GPTs? And then I quickly realised, of course, that something that was a common engineering saying back in the 1980s and the 1990s has subsequently, you know, been lost in the last few decades. So for the benefit of those younger engineers that are tuned in today, I'm going to say oils ain't oils and GPTs ain't GPTs, and that's going to be a little bit of a theme running through. Okay, and a little bit of a help, I'm going to give you a video snippet. It's an old advertising campaign. It was done by the Castrol oil company. It went a long way towards raising engineering excellence and so on, and all the development and refinement of engine oils back in the day. The Oils Ain't Oils advertising campaign, for those that can remember it, you know, was expanded across the world and became a full series and ran for almost 10 years. Okay. For those that are Midnight Oil fans, the recent and last few years has been a cover band called Oils Ain't Oils. They've adopted that slogan. So, so when Damien and I are discussing GPTs, the analogy that we're typically going to use is
Sol,
oils ain't oils.
Sol, you are in a deep trance. Now repeat after me. Oils is oils.
No. Oils ain't oils.
You can't resist, Sol.
But GTX protects engines, reduces friction. It's worth a few extra cents.
Okay, great, Mesmo. The game is up. Sol don't use nothing except GTX.
And now we're gonna watch you put yourself into a deep trench.
You mean a deep...
I mean a deep trench. And remember, soils ain't soils.
And that's where the saying GPTs ain't GPTs. And over to Damien.
Thanks for that, Dan. So the message of this first part of the presentation is GPTs ain't GPTs. And how do we explain different types of GPTs? There's 5 broad categories of GPTs that we've drawn and defined from the Australian Stormwater Industry Association Technical Guide of 2010, because we need to define these categories in some way. The OceanSave is part of the indirect screening GPT group, which contains a non-blocking screen. Gravity separators. So basically a gravity separator works by simply extending the flow path through the system, leading to a reduction in the flow velocity, and obviously in accordance with Stokes' law, this causes a separation of pollutants based on their specific gravity. But these type of systems, they're not fantastic at stopping neutrally buoyant materials. So shopping bags, chip packets, pollutants like that. But a gravity separator is not an OceanSave. Direct screening. So basically, direct screening is typically the use of a physical vertical barrier to the pollutants. So when the pollutants hit the screen, as we know, the design flow rate quickly decreases as the screen blocks up. So some sort of examples of this is the generic trash rack that you can see in the picture here. These can often be one-off designs. Vertical screens are supposed to, at the end of the rainfall event, those pollutants are supposed to then fall down just through gravity. But we do know that in practice that these pollutants have a tendency to grab into the screen. They work their way into the gaps, and then you need regular maintenance to actually physically scrape the cleans clean. These sort of categories of products also include NetTech, Rocklet Cleansall, HumeGuard, StormScepter, and EcoSol GPTs. But a direct screening GPT is not an OceanSave. Hydrodynamic separators. So basically, hydrodynamic separators are similar in some ways to a gravity separator. They basically work on the principle of extending the flow path, leading to a slowing of the flow velocity. They're much more smarter designed. They're designed with a very long flow path, and they're much better at capturing coarse sediments, hydrocarbons, oils, etc. But they do not have a screen, and therefore they're not great at capturing all of the litter. So examples of these would be the USA StormScepter, HumeScepter, EcoScepter, Cascade, Downstream Defender, and VortSentry. But hydrodynamic separators are also not an OceanSave. Combinations. There is another category, which is a combination of the previous four categories. Not many of these products you'll find that fall into this range. One that comes to mind is the vortex system, which is a sort of combination of a hydrodynamic separator and a gravity separator. But a combination GPT is not an OceanSave. So as previously stated, the OceanSave is an indirect screening GPT and the product for today's discussion. So it is estimated that since 1993, over 7,000 indirect screening technology GPTs have been installed within Australia and over 35,000 in the USA, making this type of GPT one of the oldest and most widely used technologies worldwide. Equivalents. Each of the OceanSave's products have what we call a white paper, which contains information regarding the background, operation, and maintenance of those products, as Brad is going to provide that link. In the white paper for the OceanSave, there's a letter from a third-party engineer that states that the OceanSave is achieving a device that is technically equivalent in functionality to the CDS unit.
Now on to best management practice. The first thing to consider when you're looking at best management practice is, what is the actual outcome that you want to achieve for applying these practices? In the presentation here, you can see there's a photo. It's a recent development. It's been undertaken by Fraser's Property Group over the last couple of years. It's the Shell Harbour Council. It's a construction of an entire whole new suburb. It's also a harbour precinct, a whole new harbour that's just recently been handed over to the council, and it's in New South Wales, of course. It is fairly easy to work out what the desired outcome for this project is, and it is basically to protect that harbour that you can see in front of you and to provide a nice, clean, healthy environment for the general public, and the people that live in that area. But how do we actually do this? All right. In this particular case, Fraser's and the design team, proposed various GPTs. They couple these up with tertiary treatment filters, wetlands, basins, bioretention systems, and so forth. The OceanSave indirect screening GPT was designed and installed at multiple locations throughout the suburbs, throughout the development. They have been protecting the harbour not only during the construction stage, but they will continue to provide this protection for many years to come. Now, why did Fraser's select the OceanSave? Well, they did it because it was the best practice, because the OceanSave captures the widest range of pollutants of all of the GPT types that we've just previously gone through. All right.
So this brings us to what is an OceanSave GPT. So basically today we're going to look at the basic principles and the innovative design of the OceanSave GPT. So to begin with, it is a durable, strong precast concrete cylinder tank. It's built to Australian standards. It has a special cylindrical directional screen located in a separate screening zone and a separate sump and floatable storage area. It's obviously a very high performing GPT based on Australian indirect screening technology, Go Australia, and it incorporates design improvements from the USA and Europe. It is obviously a GPT that is very easy to inspect and clean, and it's ideal for protecting our precious waterways and our sensitive environments. The heart of the OceanSave is the screen. So the screen is somewhat similar to the food grater that you find in your kitchen. It's corrugated and smooth in the direction of flow, but grated in the opposite direction. So the development of the screen was the most difficult part of during the original development of the technology. And it was really only after a significant amount of time, trial, error, test and retesting that a suitable screen was developed, which is the final screen that was used today. The schematic on the right is of the OceanSave GPT. The red arrow shows you the flow of the stormwater into the GPT, directed into the screening zone, and then the clean water passing through the screen and onto the environment. It is indirect screening technology, GPT, which means that the screening process is controlled in a way that keeps the pollutions in motion and keeps the screen clear for maximum cleaning performance. And you can best see this on the video. You can see the pollutants swirling around in the treatment chamber. So in the next slides, what we're going to see is how the pollutant enters into the GPT and follows a helical path to the sump area. So here we'll see a little red ball. We've got to assume this is probably at a dog park. Little Fido's lost his ball. It comes into the inlet area of the GPT, directed down the inlet flume, and then it's following a helical path across the face of the screen, all the way down to the sump area. And much to the distress of Fido, he's lost his tennis ball. Let's talk about some of the aspects of the OceanSave. The OceanSave allows for multiple inlets and outlets at varying heights. So the inlets can be positioned anywhere around a 180-degree arc, and this allows for much greater flexibility when you're designing stormwater systems with the OceanSave GPT. The OceanSave GPT has two unique advantages that no other indirect screening GPT can offer. One is that the OceanSave can be designed for flow splitting, I should say, sorry, and it can also be designed as a junction pit. The OceanSave GPT is available as an online or offline configuration, depending on the maximum flow rate. The system is available as an online configuration across the full models. The other main advantage of the OceanSave GPT is the minimal number of components. So in an online configuration, you're talking about 2 to 3 components maximum. For an offline system, you're talking about 4 or 5 components in total. So even in our very largest system, the 3.5 metre, 6 metre high approximately, pre-assembly means that the only connection required on site is a few bolts. So this obviously means a minimal on-site assembly, quicker installation time, and less time with an open excavation on site, which is very important because the rain's coming over right now. If you had an open excavation, you'd be in trouble. The units are load bearing in their own right, so there's no in situ concrete required at all. So this is just a short video. This is a bird's eye view of an OceanSave 1112 being unloaded for a project in southeast Melbourne. So this was part of a treatment train. This was the prior treatment before the wetland. The 1112 is made up of only 2 components. So it's basically the 2 parts that you can see here. Now the OceanSave substituted a system that was specified for this job that had 13 parts and a whole bunch of other stitch areas of in situ concrete. So the civil contractor on this job was quite thrilled with the process for them at the end of the day. So simplicity is the key, minimal number of components. Just another shot of showing you how simply that's done, with all the pre-assembly done in that bottom unit completely. And just another view of another project. As noted previously, this technology has been available for 27 years, and Daniel's going to be discussing some more of the performance aspects of the OceanSave GPT.
Damien. Right, the performance of the OceanSave indirect screening process has been conservatively based on independent research information. It is the same information that has been currently adopted by many of the council regulators and the water quality design and modelling programs that we use today. Now, it's been tabulated here and is also contained within the standard music notes, which are available from Ocean Protect directly or can be downloadable from MusicLink. All right. Now, what's noticeable here is that nitrogen is listed as 0. Although it is possible to have a net positive removal of some nitrogen from the GPTs, they generally require regular maintenance to do this. The value can be as high as 20%. However, nitrogen removal that Ocean Protect is adopting is 0, and that's to match the Blacktown City Council guidelines and their modelling for all the indirect screening GPTs they apply. Now, for best management design and selection of the type and size of GPTs, you really should consider these 5 items that are listed here. This was covered in my previous webinar late last year, which you can obviously said you can get off the website link if you need to. You really should consider obviously the location layout, the design flow rates, the desired outcomes, as well as factors such as your bypass flow, your extreme conditions that you may need to allow for. It needs to consider the pollution removal performances that you're trying to reach, and obviously needs to be sized for the amount of pollutants and the pollution loads that you are expecting from the site and to be captured. It also needs to have some thought when you locate the GPT, because these things do actually have to be maintained and on an ongoing basis. So you've got to consider that, and the cost and frequency of this maintenance comes into effect there. If you're only designing the GPT purely off the size of the pipe that you've got coming down your catchment area, I would suggest that this is not applying your best practice. Okay. Now, maintenance is not a new thing. GPTs have designed and captured pollutants, and therefore at some point you will need to remove the pollutants that you capture. Okay, it needs to be done at a fairly regular sort of timing. Sometimes it might be 3 months, it could be 6 months, could be once a year, could be twice a year. Okay, whatever. So you will need to get a truck and a personnel to get to the side of the GPT. All right. So the consideration of maintenance is best management practice. The realities of not appropriately maintaining a GPT is that the effectiveness can be significantly diminished. If you just leave a GPT full of sediment and so on, then you end up causing more polluting to your downstream environment instead of the protection that you're actually aiming for. To help those that are online here, there was a Stormwater New South Wales guideline for maintenance of stormwater treatment measures. It was released last year, I think about mid to end last year, and it's very helpful in gaining a good overall understanding of the full range of not only GPTs but of treatment systems that are available in the market, and also the pitfalls, the issues, the past designers and asset owners have encountered. I encourage any asset owners that are on today to go out and check out this document, as they will end up having a better understanding of how their efforts to keep a GPT, to keep a GPT clean and to have it ready to go for the next rain event is actually going to help protect our waterways. Now, some council engineers or council asset owners, oh, I've got rain as well, Damo. Some engineers or council asset owners may find the GPT selection process a little daunting, a little difficult, and for some specific catchment areas or locations, you may need help. So here are some very basic common layout examples. Standard inline unit, whether it be 6 o'clock, 12 o'clock as shown here, whether it be, as Damo pointed out there, a junction pit where it can actually change direction, that's fine. That's a typical inline arrangement. Again, you've got your offline arrangement where you have a diversion box and you divert to an offline tank on the side with a treatment system in it. Again, you can have a left or right in this, and you can make these change and go at different angles. Lots of different variability in how you design and configure these on site. You also have flow split, which Damien mentioned. So here's an example or two examples of flow splitting to a bioretention system. Whether they be using a diversion box at the line, or whether it be an upstream diversion system into an inline unit, there's lots of different ways. Okay, now the entire Ocean Protect design team, which I'm part of and assist to run, are happy to assist all the engineers out there, all the asset owners and so on, in correctly selecting sizing of a GPT for your project. So by all means, we're here to help. Just give us a call. Okay. All right, now it's time to wake up because I'm on the summary page. If you want to read the basic summaries, we've already talked about them. They're there in front of you. But I will say, of course, that I suppose I am a little biased, but I reckon that the OceanSave is the best indirect screening GPT that's currently available on the market today. It has some good advantages over similar indirect screening GPTs, and it's got plenty of technical advantages over the other types of GPTs that we previously discussed. Hence, I still believe the relevance of the old oils ain't oil slogan from the 90s, and the GPTs ain't GPTs. And I thank you for your time. I look forward to answering any questions you might have.
Thank you.
Thank you, Daniel. Thank you, Damien. Wonderful presentation and bang on 20 minutes. So I know both of these gentlemen can almost talk underwater all day on the OceanSave GPT. So they've done very well to keep us to time. So well done, gentlemen. As a reminder, if you have any questions you'd like to pose to either Daniel or Damien today, please put them in the Q&A tab in the Zoom window. Obviously, their contact details are here as well if you want to talk to them or ask them questions, whatever, after today, or just separately or privately. And I'd certainly encourage you to reach out and contact those guys in your own time. But look, I know we've got about 5 questions have already come through.
I can see a few of these, Brad, so I can take care of a few of them really quickly. So yes, John Gann's asking about the screen size. So normally 5 millimeters. So you're quite correct. The CDS screen that was originally developed and that we're utilising here in this as an indirect screen is exactly the same screen as Damien spoke about before. It's a 4.6 millimeter screen diameter aperture, smooth on one side, and graded on the other, as discussed.
But John also asks, can we get a different size screen? Is it just, yeah?
Yes, you can. It does change the entire flow dynamics inside the unit. It operates the same way, but obviously your flow rates and your head losses change as you change your screen apertures and so on. It can increase the performance, but it depends on what you're actually trying to target. So there was a smaller screen that was used in sewer overflow in the US. It still is used today, and it's much the same screen. I think it's a 1.2 millimeter screen from memory.
Cool. Yusuf Riyad asks, what catchment area would warrant an OceanSave rather than individual pit insert GPTs or gully baskets? Does the OceanSave negate the need for pit insert GPTs? And is there a cost assessment of how many pit inserts need to be replaced with one OceanSave to be cost effective?
Yeah, good question. Damien, do you want to answer that one, or you want me to?
Courses for courses. I mean, they're probably, yes, 2 different solutions. Haven't sat down and done that. We probably wouldn't be comparing, honestly, a complete site full of pit baskets versus one OceanSave. I think they're different type of solutions, different maintenance costs that go with that. Obviously, we believe the OceanSave is overall much better treatment process. At the end of the day, you have the one point of maintenance, obviously, but the cost of that maintenance. We find that for those applicable sites as well, access to the pits and the pit baskets as well, you know, that can be problematic because you come to a site, there's parked cars, you don't want to have to revisit that site. So, you know, they're all limiting factors depending on the site, the application, etc. In terms of the application of the GPT for sizing, Dan, I mean, we're sizing.
Wow, and I'm thinking you'd need, you know, if you got more than sort of 20 pit baskets, then the cost straight away says you're better off to put a single OceanSave in. Yeah.
Cool. And Murray Powell has chimed in, and Murray's never short of an opinion, and he's always loving chiming in. And obviously, as a side note, he's also the key author of that Stormwater New South Wales document that Daniel referred to. So kudos to Murray. And Murray says, if there's any more than 6 pit traps required, go to a GPT. So yeah, I think, was it John Burgess asked a question more or less at the same time. How does the warranty of the OceanSave GPT compare to other systems on the GPT market?
So the parts of the system itself, it's made in a precast concrete cylindrical tank. You know, it's made to AS 3600. AS 3600 provides for a 50-year durability design life. But that's a very conservative approach, because we know that concrete structures using modern concrete, I mean, they're working well in excess of 100+ years. And I could just walking around, I think we could all point to these kind of structures and see how well they're performing. So in terms of durability design life, I think you could well expect a minimum 100-year out of the current precast concrete standards and modern concrete.
Cool. David Sutherland asked a very similar question, so I hope that covers your question too, David. John Burgess asks,
well, there's no moving parts in the OceanSave, so therefore there's nothing necessarily to break. So once it's in and operational, it's decades.
Cool. John Burgess also asks, how does the OceanSave GPT compare to the CDS and other systems on the market?
I thought we pretty much covered some of that, and that seemed to be a fairly early on question, so I sort of skipped past that one, Brad. But yeah,
all good.
Obviously it's the same indirect screening technology. It's similar configurations, just improved. Yeah, we've taken on board some of the advances in the US and the Europe designs and so on of the indirect screening systems, and we've actually applied those. So yeah.
Cool. Yeah, all good. John Milkins also asks, he's interested in knowing whether Ocean Protect is considering the opportunities that are starting to be realized in IoT technology for remote monitoring, i.e. smart GPTs. I can answer this question if you guys want me to. Yeah, so we've actually, people might be aware of the fact that Ocean Protect are a partner with CSIRO. So we've done a bunch of collaboration on them in relation to innovation and data analysis and gathering, etc. And one of the innovations is a remote technology to monitor GPTs, essentially monitoring to see how full they are, and if they get to a certain capacity, some sort of trigger or notification is sent to the asset manager, and they can appropriately schedule the maintenance in accordingly. That isn't commercially available just yet, but hopefully it isn't too far away. And it's not an Ocean Protect technology; it's a CSIRO innovation. We're just essentially helping them with the key goal to essentially reduce the amount of pollution going into our oceans and waterways. But yeah, great question, John. A couple other questions have come through in the meantime. Carl Hassan asks, besides the third-party letter from Lars Harrington specifying the Ocean Protect as an equivalent to the Rockler CDS unit, what other testing is available? Is there test data similar to the validations and tests provided by Monash University?
Damo, you got anything on that one you want to go through?
No, obviously, as a the OceanSave is certified as technically equivalent, and thus the testing that's applicable to the CDS technology is applicable to the OceanSave in that way. The Monash University, it's not occurring to me, Carl.
The Monash University studies weren't that fantastic, and they weren't very they were done a long time ago, you know, 90s sort of thing, mid to late 90s. There's been a lot further studies done on the on CDS systems throughout the US and so on, so I'd actually would suggest that the monitor is actually very early days sort of status stuff. So.
Yeah,
but the
just on that,
OceanSave is effectively exactly the same.
And yeah, like there's referred to a few studies there, but if you want to click on the OceanSave white paper, that it refers to about, I think, 6 or 7 studies that have been undertaken to date. There's a couple of questions coming through. Have you got any testing sites, or do you just rely on other manufacturers' testing? So, look, I can try and answer that if you like, but chime in. We are currently not undertaking any testing for the OceanSave device. We've got a number of test sites, but the OceanSave technology isn't one of the devices that are currently being tested. Russell, sorry, did you guys have any further comments on that? Is that?
Yeah, I agree with that. There's a fair amount of cost involved in doing any testing. There's no real warrant for testing of GPTs. They've been around for so long now that, and they've been accepted so well across the across Australia, across the world, that there's no real advantage in whether it's X number over a Y number. It's they're all being sort of shoved into those type of groups that we previously discussed in this presentation. So the performance of each group's fairly well known.
Cool. Yeah, John just thanks us for the answer on the remote sensing technology. John, if you're actually interested in more information about that, probably contact me separately, and I can provide a little bit more information as well. Russell Cadman asks, do you need to do a confined space entry to clean behind the screens during a comprehensive clean?
Technically, any below ground tank, such as the OceanSave or pretty much majority of our products that we actually install below ground, are all confined space entry points. So regardless of whilst you may not need to get into the tanks to do those cleans, because they can be done using suction truck from above, they're generally undertaken by staff that have actually got confined space credentials and so on. So it's a bit of a weird one. You don't need it, but I would suggest that most already have it.
Cool. I think John just asking a couple more questions, and he does apologise for all the curly questions he's giving us. But John, we love curly questions. Keep them coming. John says, just reading the white paper, and it says he's done well to read the paper already. But he says, reading, and it says a 50-year life. Do you have a link to the 100-year document? I think
I can send some more information to John. I mean, we're talking about modern precast concrete structures and the applicable Australian standards and references to those.
Yeah, majority of the standards only go for 50 years as a default, but obviously most of the standards actually can be applied for longer periods.
Correct. There's some commentary. There's plenty of commentary about modern precast concrete and its ability to stand the test of time, and we all see those everywhere that we go.
Cool. Thanks so much for everyone who's asked questions. I reckon we might have to wrap it up there. I'm just conscious of time. I'll give you people 2 or 3 seconds to chuck a couple of questions if they want. But look, just a reminder, if you missed out on anything or you want to ask something further to Daniel or Damien following today, their contact details are there. I know they both love a chat and they love talking about GPTs and they love talking about the OceanSave. So if you've got a couple of days to spare, give them a call. No, I'm kidding. But just a reminder, there's obviously a whole bunch of information in that white paper as well, if you want to refer to that. A recording of this webinar will be on our website under the webinars tab by tomorrow. But look, on behalf of Ocean Protect, I'd like to just personally thank Damien and Daniel for giving up their time and efforts and energy to share their knowledge and expertise today. It's a great presentation. And again, thank you everyone who's dialed in today. Another great turnout, went out well over about 110, 115 people, and they basically stayed around for the whole thing. So again, thank you everyone who's dialed in today. Again, we've got another couple of webinars coming up the next couple of months. If you're keen to register, just jump on the Ocean Protect website under the webinars tab and please do so. And we look forward to seeing you guys shortly. Again, thanks Daniel, thanks Damien, and thanks everyone.
And thank you everyone.
Enjoy the rest of your day.
Thank you everyone.
Bye for that.